Hello everyone, Dylan here, and welcome to Advent of Code Day 5, 2025 in Python. I hope you find this solution helpful, and remember you can always check the code down in the description with the GitHub link. So let's go ahead and get into it. So taking a look at Day 5 here, it seems like we have some ranges of ingredient IDs and then the ingredients themselves, and it seems like any ID that falls within the range is fresh and is okay, but the rest of the food is spoiled. So what we need to do for this problem is find how many of the ingredient IDs are fresh. So how many of the IDs fall into the range. So taking a look at what the input will look like, first we will have some ranges which may overlap or repeat. And then we also have some IDs at the bottom separated by a new line. So let's go ahead and get into the code. So taking a look here, the way I read in my input is I read each line into a list, and then I work with the list in my parse function. So you should work with your input accordingly. But what I'm going to do is I'm just going to search for the line or the item in my list that's a blank line, and because we know that's separating the ranges from the IDs. So I'll just take for I in range and the length of my data, and if the data of I is equal to that blank line, then we'll just stop searching. And then we can say ranges is equal to, and I'll just say r.split, and these are splitted by the dash for r in data, and we'll just take everything up to I, and we'll just convert these values to integers. So ranges is equal to a list of tuples where we have int l and int right or int r for L and R in ranges. Okay, and let's take a look at our ingredients. So first we'll just take everything in data that is after the I index. So I plus 1 onwards. And then ingredients is equal to, we'll just turn these into ints as well. Int I for I in ingredients. And then we'll just go ahead and return the ranges and ingredients here. And then I'll just go down to my part 1 solution here, and we'll say ranges and ingredients are equal to parse data. And what we're going to do is for each range, we'll just check all the points to see if it's in that range. But because there's overlap or repeats, maybe we'll count the same ingredients multiple times when it should only be counted once. So we'll just make a set called checked, and once we check an ingredient and find it's in a range the first time, we'll add it to checked and then ignore it all the other times. And then we'll also take total is equal to 0. Now, I realize this is not the most efficient solution, but I think at the end, after we've solved both parts, I can show you how to optimize. Okay, so we'll just take for, I'll say for left and right, meaning the left end of the range and the right end of the range in ranges, and for I in ingredients. Well, first, if I is in checked, then we'll just ignore it and continue. Otherwise, if L is less than or equal to I is less than or equal to R, then total will be incremented by 1 and checked dot add I. And then at the end, we can just return our total. So if we go to give this a little run, we get 726. And checking our input here, perfect. That's a good solution for part 1. So taking a look here at part 2, it's asking to know how many possible ingredient IDs are fresh, are valid. So I kind of expected this kind of problem for part 2. There's actually been something similar in a previous Advent of Code year. So what we're going to need to do is take a look at all these ranges and combine them down so we can get rid of anything that has been overlapped or repeated. So let's go ahead and take a look at the code. And the first thing I'm going to do is make a function to combine the regions. And we'll just take in some data. And for this, let's see. And the way this is going to work is we need to get a list of all the lower end of the regions and a list of all the higher end of the regions. And if we sort each of those lists, then we can kind of just iterate along it to find where a gap in the region is. And a gap in the region is defined by when you have an upper bound, and then the next lower bound of a region after it is going to be greater than the upper bound. So if we have a lower bound that's greater than an upper bound, then that's indicative of a gap in the region. So we can just iterate along to try and find that. So first we'll take lows and highs, meaning the lower bounds and the upper bounds of the regions, and those will just be blank lists for now. And then for low and high in data, lows.append low and highs.append high. And then finally at the end we'll just say lows.sort and highs.sort. And again, sorting is really the key here because that'll just allow us to iterate along nicely. So we'll return a list of ranges, and we need to keep track of where we are in the list. So I'll just do that with some variables called L and R, initially set to the beginning of each of their lists. And what we can do is while L is less than the length of lows, and you'll see why this is in a minute. Basically, we're going to always assume that L is on the correct lower bound of a region. There may be other lower bounds, but that would be something that's overlapping the other region. So L is always on the left side of the gap, or at a gap, not in the middle of a region. And what we're going to do is if the position that is R plus 1 away in the low list is greater than R in the highs list, then that means we have a gap. So we basically need to be checking highs of R against lows of R plus 1. Now in order to make sure that we don't go out of bounds here, we'll just also check if R plus 1 is less than length of lows. Because if that's not the case, we'll be checking out of bounds and get an error. And then highs of R, if it's greater than or equal to lows of R plus 1, then we have not found the bound to a region yet. So let's just go ahead and increment R by 1. Otherwise, we have found the bounds of a region, a gap. So we should say ranges.append, and we'll make that a tuple of lows L, and then highs R. And then we should increment R by 1 again, because we've already dealt with this upper bound. We don't want to look at it again. And then we'll set our new L is equal to our new R. And remember, like I said, we can always assume, we always want to create a situation where we can assume that L is the true lower bound of any given region. And we just found it here because it failed this check. So we know now that L is going to be that R plus 1 from up here. And in the end, we can just return our ranges. And if we go down to the actual solution for part 2, we'll just say that ranges and underscore, because we don't actually need the values for this part. is equal to parse data, and ranges will be equal to combine regions of ranges. I don't know why I named it regions, combine regions. I should have named it combine ranges. And we'll just say for total is equal to 0. And for low and high and ranges, we should add total plus is equal to just high minus low. And since it's inclusive, we want to add back 1. And the reason why we do that is if we have a region, say, from 3 to 5, if we just subtract 3 from 5, we'll get a size of 2. But because this region should include 3 and 4 and 5, the answer should actually be 1 more than that subtraction. So finally, I'll just return the total here. And if I go ahead and give my code a run again, and that was really dumb. I forgot my return statement here in part 2. So if we give it another run here, we get a big old number. And if I go ahead and try that out, perfect, that's a good solution. So like I said, I want to show you how we can optimize part 1, and we will go ahead and do that using some of the code here from part 2. So I'm going to go ahead and move my combined ranges all the way up here, maybe above my parse, doesn't really matter. And what we can do in part 1, I'll just save this as part 1 slow. And for part 1, we'll go ahead and start the same as the last one, where ranges and ingredients will equal to parse data. And then we will just combine the ranges here. So ranges equal to combine regions. Once again, I don't know why I called it combined regions. It should be ranges, but it doesn't matter. Already this is enough to kind of improve on part 1 because we have at least eliminated any extraneous regions, but we're still checking the ingredients every single time. And I'm not even sure what O notation this is, but it's too much. We got a loop inside a loop. So we can actually do this in constant time, or not constant time, linear time, which is pretty darn good. So the key to this is we need to sort our ingredients list, and you'll see why in a second here. And then we can just kind of count them up in place, if you will. And then we can just iterate along one time to count them all up. And the way this will work is we'll take the bound of the first region, and we'll just kind of ignore everything that's lower than that bound, and then we'll count up for everything that is up until the upper bound of the region, and then we just kind of do that until we're all done. So I am going to take an ingredient I, and that's going to equal to 0. And that's just going to be the position in the ingredients list that we're on. And then I'll take our total is equal to 0. And then we'll say for left and right in ranges, let's go ahead and skip everything below the range that we're checking. So while ingredients I is less than our lower bound there, L, then let's just increment I by 1. So we'll go along until we actually find something in the region. And then let's count everything that's in the region. So while I is less than the length of the ingredients, because we don't want to go out of bounds here again, and ingredients I is less than or equal to that upper bound R, then we'll say total plus equals to 1, and I is also plus equals to 1, so that we can keep going along there. And so basically what this will do is for every range, we will ignore everything below the range, then count up everything in the range, and then move on to the next range, repeat until we are finished. Then we'll go ahead and return a total. And let's just go ahead and run that again to make sure that it still works. Yes, it does. And over here in my terminal, you can see I ran the code with some timing. This is actually my other Advent, my personal Advent of Code account, not my one for YouTube, so the answers are different. But either way, you can see the original solution here took 0.0068 seconds, and our fast solution took just 0.11 seconds. So our fast solution seems to be about 6 times faster than our first solution. So I think that's a pretty good optimization. Anyways, that has been Advent of Code day 5 in Python for 2025. So if you found this video helpful, especially the optimization at the end, please leave a like, and I'll see you again tomorrow. Bye.